Hi, this is a SQLite GPS lost item tracker. This program uses Python and SQLite. Main purpose is the user can save information about the lost item. The program stores the data into SQLite databases. So this projects demonstrate first creating SQL databases, tables, query a table data in the select, adding a data with insert, updating data with update, deleting a data with delete. And for the stretch challenge, I filtering by date range. So starting with this, importing the SQLite in here, and after that, if I run this program, it will create the file automatically as long as it's not exist. And then this function connects the Python programs in SQLite basis, and I use it whenever I need to read or write a data. And then this whole functions here creates the table for my lost items and it runs when the program starts. If the table already exists, it will not create a duplicate table because you already use create a table for not exist. Okay, and this commit saves in data files and ends the connections. And then this functions here lets the user add or new a lost item. This makes the requirements to add a new data to the databases. The user types the information and then program uses an insert SQL command to save it into the lost item tables. And then they insert the new um, this whole thing. Here's the inserts as a new record to database. The questions marks on the placeholder. They make the SQL comments safer and allows user input to be edited. Like till here. Added safely. Okay. And then this functions shows all save losses item. This meets the requirements to query it from the databases. So that means get all the columns from the lost item in the data. If there are no records, shows a simple message here. And then each item else and each items is the one row from the databases and item 0 is ID, item 1 is the ID name, and so on. And then this function searches for an item by the name, and this is another example of querying the databases. I use like to the so the user can search with the part of the name. For example, searching in the wall can find like wallet and the percent signs means the keyboard can appear anywhere in the item names. And then this functions here is update existing the lost item. This makes the requirements to update the data in the databases. The user enters ID of the item they want updated, and then the program changes the lost known the location and status and update the existing data where ID equals makes sure only one specific item is updated. Okay, so let me show you. Okay, and then this functions deletes an item from the databases, and then this meets the requirements to delete from the databases, and then delete removes a record from the databases. The last one is this function is like a main stretch challenge. The table has the date lost in column. This function lets the user search for the items between two dates. The dates format like it should be year, month, and date. Um, and the between the filters records between the start, the date, and the end date. And then this demonstrates using the date columns with the date range query. And then lastly, this is the main function. First, it creates a table if needed, and then it shows the menu over and over until the user choose exists. So depending on the user's choices, here the program calls different functions, and this starts the main. So if I run this query, it will show the GPS lost item tracker. You want to add view all items search by item name. So if I add one item name, let's say wallet, Description is like a brown wallet. Tommy, I don't know, brown wallet. Lost known location, it will be my kitchen. Date loss, probably like 2026. Today's the date, May 22. Status, loss. Yeah, I don't know what happened on the before, but it would say item added successfully. So when I see view all items, it will show that we use all the items. And if I go to this databases, it will show the table here that wallet, brown kitchens, and then have I lost it or not? That's it.